Hola
Buenos
Antoine,
días.
buenos días. Bueno, voy a pedirle, pues Carlos, muchísimas gracias, de verdad.
Gracias por todo.
Muy buena. La idea es que los chicos queden muy en relación con los conferencistas contigo. Bueno, entonces yo le pido a Sergio, gracias, sí, Sergio, presentar nuestro siguiente conferencista. Antoine Monterrat va a presentar su charla llamada, bueno, I'm going to switch to English, Development of Renewable Energy Projects in Emerging Countries, a focus on Africa. So welcome, Dr. Monterrat. I'm going to introduce you to the audience. Antoine Monterrat is a senior renewable energy business developer with a strong experience in large-scale renewable power projects, hybrid energy systems, and international project structuring. He currently works at Total Energies as Senior Business Developer Africa, where he leads the development of wind and solar projects totaling 780 megawatts, including land acquisition, permitting, grid studies, PPA strategy, stakeholder engagement, and government relations. He also managed a strategic industrial partnership for 430 megawatts of hybrid projects focusing on co-development, commercial structuring, and PPA negotiations. Previously, he contributed to major renewable energy initiatives in Africa, including 1,500 megawatts hydro project in Mozambique developed with EDF and Sumitomo Corporation, as well as solar PV projects and project company governance. Earlier in his career, he worked as a hybrid integration engineer, developing methodologies and tools for integrating renewable energy into oil and gas assets with responsibility in innovative projects exceeding 5 million euros annually. Antoine has a strong technical and academic background, holding degrees from PS University Mainz Paris Tech and the École Normale Supérieure de Cachan, with expertise in energy systems, electrical and control engineering, economics, and management. His skills include project management, strategic planning, stakeholder management, contract negotiation, financial structuring, energy economics, technical analysis, and tools such ETAP, PVC's MS Project, and Python. He also contributed to international research in renewable energy integration, including publications on the techno-economic assessment of variable renewable resources and marine renewable energy grid integration. One of his IEEE conference papers received a Best Paper Award. Very short version. Thank you very, excuse me. One of his IEEE conference paper received Best Paper Award. Dr. Antoine, the floor is yours.
Thank you very much for the presentation. Just to correct that, I'm not a doctor. I didn't do a PhD, but I stopped at the masters. But thank you for the introduction, Professor, and thank you, Dr. Carrejo, for the presentation earlier. I think it was very interesting. I will try to share my screen, but just before I had the opportunity to start my career at Total Energies with Dr. Carrejo, who taught me a lot of what you have had the chance to see in his presentation, and I will explain a bit more about my journey as an engineer at Total Energies. Let me see if I can. Okay. So yeah, my presentations will be in five points. First introduction, but Professor, you already gave a lot of context. Then I will be also introducing Total Energies' ambition and the strategy in renewable development, and finally I will provide a use case and project finance in Zambia before concluding. So first, I wanted to thank you very much for the invitation and the attendance. It's a real pleasure to be presenting in front of you guys today. If there is any questions, please feel free to interrupt, or we can leave it at the end as you prefer. So I'll be quite quick, but as mentioned, I started, let's say, in science as an engineer. I did engineering schools in Paris. So my background is on electrical engineering. Engineering. I did electronics, power control, yes, and it was mostly oriented to research, and I did some experience in academic environment, such as in Ireland, where I worked on marine renewable energy integration to the grid, and I also worked in Brazil on a power conversion system for the more electric aircraft. So. And after that, I joined Total Energies in 2019 as a hybrid integration engineer. So my focus was especially on decarbonizing the oil and gas assets, and and I was also part of the journey described by Carlos on the academic collaboration on clean energies to develop partnerships with the different geographies that were mentioned, especially DTU, Qatar, and Brazil and the US. So very interesting 4 years as both R&D and technical engineer. So and after that, I wanted to let's say to have a closer impact to business. So and as R&D is preparing for the future and with new technologies and so on, I wanted to actually develop projects in countries that are definitely needing energy, clean energy, affordable energy, and available energy. So. So now I'm working on yeah, on solar, wind, hydro projects, and and especially in Africa. And there was three points that I wanted to mention is that engineering is a great background to also do business and to have impact on the real world. Power electronics, and I don't know exactly what you're studying, but I suppose that we have a similar background. But these are really key: understanding the grid system, the strength of the grid, and to further develop and to understand where we can build renewable power and clean power when it makes sense, and how to do it. Technically speaking, I think it's an important basis. And yeah, I think that science is also bringing a lot of tools to the real world, and then helps you to it gives you a framework to be able to think and to understand what you're doing when you're designing systems, when you're thinking about new technology, new control strategies, and so on, and then to be able to innovate and think out of the box. So that was my second point, and last. And last is that energy transition, and as we are yeah, facing the current events in Europe with the heat, it's really important that we are able to make this transition from the, let's say, oil and gas power generation to more renewables and cleaner energy. So this is all about people. So there is a lot of then contracting of business, and that happens with people. So my presentation will be a bit also about it. So I will just quickly mention a few words about Total Energies' ambition and strategy. So Total Energies is motto is to bring more energy with less emissions. So it is a global integrated energy company, no longer an oil and gas major, even if there is still a strong footprint in terms of oil and gas. But the Total Energy is committed to provide as many people as possible with energy that is reliable, more affordable, and more sustainable. So there are two pillars in the strategy, in the multi-energy strategy, with oil and gas, notably liquefied natural gas, electricity, and energy for the transition. So the plan is to increase its energy production by 4% per year between 2024 and 2030. And Total Energies is active in 120 countries, with sustainability at the heart of its strategy and its projects and operations. So in Total Energies, I'm located in a branch that is called Gas, Renewable and Power. So there are 10,000 employees working in over 50 countries in this branch, and the objective is to play as a global integrated player in electricity and gas. So first on the gas is to remain in the top three of the LNG players, and increase both production and long-term purchasing, while investing in biogas and in renewables. Um, Although that we are seeing that the other oil and gas majors that were investing in renewables in the recent years, they are now going back and closing, selling all their renewable assets. Total Energies is the sole company that is still investing massively in renewables and aiming for 100 terawatt hour of net power production on different assets, so solar, onshore wind, offshore wind, but also flexible facilities like combined cycle gas turbines and energy storage, especially battery energy storage systems, to provide clean, firm power and avoid the intermittency issues into national grids. So So yeah, as part of the strategy, there are strong drivers for power demand. We are well, we nowadays we are talking about AI, about cryptocurrency, those kind of things. So there is a strong power demand from data centers, digitalization, decarbonization, electric vehicles, heat pumps, AC. So this demand will be met through more renewable production. The issue is that the renewable power plants are intermittent, so there is a need for flexible generation, which the aim is to compensate this with either gas turbines or battery storage system. And so I'll be quick on this one, but mostly in GRP, the aim is to have 70% of the power coming from renewables and storage, and 30% from gas, to be able to provide what we call clean firm power, and able to trade on integrated markets and grids. So especially in Europe and in the US, but also in other geographies like Brazil or South Africa, for instance. Yes, this is the footprint of the portfolio of Total Energies in renewables. So as you can see, we are located in all regions of the world, and the portfolio is rather big. We have 109 gigawatts of power plants, either in operation, under construction, or in development. And now I wanted to go a bit further on the renewable value chain, and especially what we are doing as developers in the industry. So the first thing is to originate projects. So the business development is here to either find suitable projects through merger and acquisition, or tenders, or greenfield. So basically, we have a large team of business development that is investing time and money into finding the best possible location and best possible projects in the world. So on my case, it's in Africa. So we are doing resource assessments for wind and solar to identify what are the best locations, and then we are once we have let's say, an embryo of a project, we try to identify what would be the business model to find a tariff, and then an off-taker that would be ready to pay for the power plant in for 10, 15, or 20 years. And then once we get the project, the idea is to develop it. So, and development is mainly about reducing risks for enabling the construction. So the project developer is here to ensure that all performance and strategic requirements are met before we reach to construction. So there are financing, contractual strategy, contractor selection, coordination, and partnering. And we'll discuss a bit more about what does it mean in real life. And then once you're ready, once you have the financing, once you have all the permitting, you can build. And well, construction is mainly about respecting budget, timeline, and ensuring that everything goes according to plan in a safe environment. So avoiding any kind of accidents, will it be to the environment or to people, which is very important, especially for Total Energies. And after that, part of the model is to operate and maintain the power plants with operation and maintenance teams that will be monitoring, operating, and also improving the performance of the asset with optimization, data monitoring, and all these kind of things. So I finished with the presentation of the company, and now I wanted to go more into a use case in Africa, where I'm currently working, and especially in Zambia. So Zambia is a austral country based in south of so near South Africa. It's in the north of South Africa, and it's especially a landlocked country, so there is no access to the sea. I will let you find on maps where Zambia is located. Before working there, I didn't know, so I don't blame you if you don't know where the country is placed. But what is interesting in this country is that there is tremendous solar resource. The solar output is very high. The capacity factors are in a range of 20%, and for wind there are also huge wind resource. If you can see in the eastern province here, there is a corridor where the wind is extremely strong here and here. So there are two places where the wind is strong. And also, if you look at the country, it's located between Mozambique in the, let's say, southeast, and DRC, Democratic Republic of Congo, where a lot of mines that are positioned here. So in the northern part of or central part of the country, we are located at the Copper Belt. So it's named after the huge resource and the high, let's say, high copper fraction in the earth. So there are a lot of mining companies that are requesting a lot of electricity, because they're here. The problem here is that usually mines are operating on diesel generator, and diesel generator are quite problematic because they consume a lot of diesel, and diesel is hard to logistically bring to the country, so it's very costly. And it's also very high in terms of CO2 emission. So the mines today are the best customers to provide renewable resources. And this is why our project is aiming at selling to a copper mine that is located in this region. So Mozambique is also gifted with high hydro capacity. I think it's the same as in Colombia. There are a lot of hydro. I think that almost 90% of the electricity is providing from hydro. And it is good because hydro is flexible, but in the other way, having only one way, or one source of energy is also problematic, because Zambia is also facing major droughts And when the reservoirs level are low, there is a lot of curtailment or load shedding, and people are staying in the dark for 12 hours. So this country is both about a lot of challenges and a lot of opportunities. So I will go to the next slide. So these kind of slides are the ones that we are doing before we are entering into a country. We are trying to identify what are the mix in the country, what is the regulatory status, how to penetrate the market, what is the right way, is it a liberalized market or not, and how can we fit into this market. So the key highlights are threefold. So first, there is a huge energy crisis due to droughts. So here there is a high need for energy, meaning that it's good for renewables. Then the market is regulated. It means that the government is owning the utility. So the TSO, the energy provider, is one entity that is state owned. In this case, it's called ZESCO. Um, so there is and there is also a few players that are able to come to the market, because there is a new trend of opening the markets to private sector. And so here is why we are also able to come into the market. And we are seeing that renewables capacity is increasing, but mainly in hydro. So it doesn't change the problem that they're facing with the load shedding. And and then the opportunity is also there, because only 54% of households are connected to the electricity in 2023. So there is also a real need for power into just for people actually. So yes, then well, this graph is also showing what kind of markets do we have. So from a monopoly that is regulated by the state to a full wholesale and retail competition with a market that any kind of player can enter. So here we are located into a hybrid. So it's historically regulated, but now what CPPA is corporated power purchase agreements that are allowed, and that enable two private parties to enter into a power purchase agreement. And um, and and basically a company like Total Energies can create a project and create a power plant and sell it to a potential mine or industrial player through the national grid. So if we look at the business case here, uh, so we approached a mine, so a copper mine that is located in the province that I showed earlier, and that was really interested into having a hybrid power plant. But the thing is that on the mine site, the wind wasn't blowing. So we had the project in the southern eastern part of wind, and we had to use the grid to be able to provide power to the copper mine. Why hybrid is good is because during the day solar is shining, and what we're seeing is that at night wind is strong, and also there is a seasonality complement that is brought when in winter solar is bringing a bit less of power, and winds are stronger, and during the summer is the other way around. And we are seeing that, well, even if winter is not very cold in Zambia, there is a rainy season where we can also see this complementarity. So the mine was quite eager of reducing their diesel consumption with this kind of hybrid solution. So yeah, when you do some kind of a project card, we're seeing that So we have two projects, one 200 megawatt, 225 megawatt peak of solar, very close to the mine, and one wind farm in the Eastern province. So it's approximately, in terms of location, the solar power plant is 5 kilometers or from the mine, so quite easy to interconnect. But for the wind, there is 700 kilometers that separates the consumption from the production. So as a developer, the first thing that you need to do is to secure the land. So either through land lease or land rights. So for the solar, it's quite easy. We are doing it at the site of the mine. So we just need the land lease with the mine that is buying the power. So it's quite straightforward, let's say. But for the wind, here there are often communities that are located there. So here the idea was to involve communities, and I will be talking about it a bit later. But to involve them in owning a part of the project, and granting them a shareholding that would allow them to have dividends over the lifetime of the power plant, which is helpful for acceptance of the project, and also the development of the local communities, because it will bring jobs, and economic development um, in the area. One point that I wanted to mention as well is that, if you can see here, Zambia is, as I said, landlocked, and one of the challenge is to bring the equipment to the site. So, for example, for the wind, equipment is going to come from Mozambique. So here there is a lot of technical analysis that is done for the logistics to bring the equipment to site. And there is like 130 bridges that is separating the closest port to the site. And the engineers had to find let's say an analysis on how much weight can each bridge support. And when we are talking about wind turbines, we are talking about packages that are well, for the blades, it's 100 meters long, and for the nacelle, for instance, it's 120 tons. So there is a need to make some innovation for splitting the nacelle and then reassembling it on site. One other thing that is tricky for this project, for instance, is that if you look at the tower of the wind turbine, um, when you're doing with steel, the lower part of the turbine is around 80 to 100 tons. And for instance, all the bridges that we were mentioning just before can only support 60 ton. So this was a big issue for the feasibility of the project. And one innovation, for instance, was to build concrete towers for the plant. In a way, concrete has the same, let's say, carbon footprint as steel tower. But the advantage is that you don't have to bring the steel parts from the port to the site. And you also provide additional jobs with a cement factory on site. So you can build those towers on site, and reuse it for potential other projects in the area. So this is one of the benefits. So once you secure the land, you need to secure the grid. So here we have been doing a very also innovative framework for the grid wheeling, because what what you're doing when you're contracting with a private player such as the mine, you need to go through the national grid, and and it is the first of a kind where you actually not deliver you don't sell the electrons to the utility, but you sell it to the mine, and it goes through the national grid. And for that, you're paying a fee, like on a highway, like a toll, or yeah, a fee, and which is called a wheeling fee. And you need to manage all the accounting of the electrons, and and from an engineering perspective, it's quite funny because you need to do it in a contract, and there is no like there is very little equation, and so you need to bring it into money and how the electron that is produced is going to go through and will be delivered. So there is an interesting, let's say, scheme where you need to account for the electrons that are made available at the plant, then that are injected to the grid. So here there might be some curtailment due to the respect of the grid code, and this is important because what we what Carlos has mentioned just in his presentation is that the power plant needs to comply with the grid code, and if it doesn't, you will be curtailed and you will not be able to submit your electrons to the grid. And when the electrons are going to the grid, they need to be delivered to the plant. And here there is transmission loss that you need to account for. And so all of this is managed through a contract. And it was the first time that I saw those kind of contract, and it was also quite new. So here you're bringing, let's say, math and physics into, let's say, more legal framework, and it was quite interesting in terms of the details on how it's done. So yes, as part of the grid connection, you do a grid impact study, you do the grid connection approval, the wheeling that I was talking about. Then you do all the permitting. So you need to perform studies, environmental and social studies, and then submit all the permits to be able to build your plants on the site. So construction permit, obviously. And then you also have the power purchase agreement, which is with the customer, with the client, that is also ruling the way of how your electrons are going to be sold. So once you reach all these steps, then you go to the banks, to the lenders, and you say, I have a great project. Everything has been secured. I need some money to borrow in order to build the construction. And once it's built, I will be able to reimburse like you would be doing for a mortgage, for instance. But here we are just talking about hundreds of millions of USD. But it's very similar to that. So during the operation, you're producing electrons. You're paid for that, and with the payment, you're able to reimburse the debt and the banks, and also you can make a bit of dividends and money out of it, which is called the return. Basically, you're working that with a financial model to ensure that you can make also a profitable and bankable project. Okay, so here is a bit of a reminder of the map for Zambia, and a bit of a project planning of what needs to be done. So I mentioned most of it. First, you need to find the off-taker. So to whom are you going to sell your energy? Then you do all the environmental and social study through biodiversity impact assessment, social impact assessment, and then environmental and social feasibility study. Then you submit it to the environment agency. So usually it's the ministry of the one of the ministry of the government. It depends on from one country to the other. But then you have this impact assessment approval, which means that you can build your project, that you have identified all the potential issues. So for instance, I showed you before there was two corridors of wind in Zambia, and in the northern corridor there is a lot of bats, and it's actually Zambia is hosting the largest bat migration, so the largest mammal migration in the world. We're talking about up to 12 million individuals that are gathering into a park that is called Kasanka Park. And for that, all the projects that are located in that region were cancelled. So it's just to mention how important the environment is for the projects, and it can definitely be a project killer. So here as well, there is some smart innovation for the wind turbines to avoid any damages to birds or bats. For instance, we can hire the sorry the mast so the size so the height sorry of the tower, so to increase what we call the ground clearance, so the point between the lowest point of the tip of the blade when it goes close to the ground and the ground. So this is called the ground clearance. And if it's high enough, the birds and bats will not be affected and will not be able to go so to be hit by the blades to be straightforward. And other technologies are that you can also, it's quite easy. You can do active curtailment. So you do detection through camera or lidars. You can do detection of birds or bats, and then you just stop the turbine to ensure that it will not have any interaction with the bird. So this is quite effective, especially you can do it during nesting or mating season, and this also allows the turbines to operate in a safe way for the fauna. So this is what's done in the ENS studies. Then you do all the grid studies. We discussed a bit about it. I have another slide on it. You negotiate the land to ensure that you have the rights to operate. Then you do all the technical studies. So we mentioned resource assessment, so wind, solar. Then you do for instance, here the logistics study that I mentioned already, the project design, and then you go to market to find the engineering, procurement, and construction firms that would be keen on building the project under your management. Then you do a tender to ensure that you get the best prices for the capital expenses. So all the PV panels, procurement, and then the construction. For the wind, you need to find the turbine supplier. So, for instance, Vestas is part of the different suppliers that you can find in the world. Now it's mainly also Chinese providers. And then you do the negotiations for the EPC contract before you can sign it. And the last part, which is the most important, is the financing work stream, where you need to do a market sounding for the lenders. So for the lenders, there are, depending on the risk that your project would have, you have a blend of DFIs, so like World Bank, African Bank of Development. There are also some European banks or Chinese banks that would be interested into investing in these countries. So you make a project teaser. You go to see that you are seeing them. You're selling your projects, and then they would say that they would be interested to invest X million of USD into your project. And then you make a benchmark of each of the lenders to find the best terms for the debt and the risk, and then you mandate them. And part of the project, what we call project finance, is where I didn't explain that, but it's when you're having both, you're putting both equity and debt in a project. And when you're putting that, you need also to recruit advisors to ensure that the lenders are understanding all the risks that are behind the project. So you do this advisor selection before the lenders are actually doing a due diligence on the projects, and that would be okay and keen on providing the debt, so you can do what we call a financial close, where the debt is ready to draw down before you can do the construction. So my job basically is going from the very beginning, when you just have an idea, to when the debt is finalized, and then you can proceed to construction. And then I just I give the project to the construction manager at this stage. Yes, I noticed that I mentioned many things, and I wanted to keep some time on the questions, on the Q&A. But basically, here is another map where you can see the interconnection in Africa and in developing countries in general. The problem is the interconnection. So here you can find a 330 kilovolt infrastructure that is basically the backbone of the country. And the projects are only performing what is mentioned here, 30 kilometers interconnection to the next closest substation. And for the solar project, we are doing what we call a loop-in, loop-out interconnection on the existing KV line. So the only tricky point is that you need to cut this line just to connect. So at some stage, you'll have to disconnect the grid for some point for the work to be done. So this is the risky part of the implementation, but it's rather simple in technical feature. I already discussed about the hydro. The fact that Zambia is mostly focusing on hydro in terms of the energy mix, and the fact that they are facing severe load shedding due to low water level in the dams. So I won't spend too much time, but basically the network is quite stable. The availability is above 99%, so it makes it quite with a low risk in terms of grid availability, which is quite important because in other countries the availability of the grid is really poor. Here, the only problem is that is the shortfall. Demand is high, but production is quite low, so they just need to curtail the demand. But except than that, the grid is stable. Well, I'm not going to tell you that you need at all time to have the demand that is equal to the production to ensure the electrical stability. And and doing this load shedding is the only way that Zambia has found to ensure that the voltage and the frequency is kept without having any kind of blackout. So they are kind of managing the demand rather than losing their network. So yes, I think the last part that I wanted to mention is the contractual scheme and just to show the complexity of a project, of doing a project in project finance. I already mentioned all these stakeholders, but just so you see that there are so many contracts to be able to launch the construction. Basically, lenders would be looking at having all the contracts that are negotiated in a bankable form, and I'll just show a bit of of how it's done in project finance. So basically, what TT, for instance, would be Total Energies. They would be partnering. I put 50-50 in terms of shareholding, but you can find any kind of arrangement. And these arrangements are done in a joint development agreement. Basically, Total Energies will find a developer, a local developer that knows well the area and the context, and then they will do a joint development agreement to know how to handle the different work stream that I mentioned before and how to spend the development expenditures that are needed to perform all the studies that are necessary. So, and then once that is done, they also create what we call a special purpose vehicle, where the project is going to limit all the risks to the shareholder, and the debt is going to be contracted by this structure that is basically a project company. And the project company will hold all the contracts with the engineering, procurement and construction EPC contractor, the O&M contractor. The land lease that we mentioned earlier will be also held by this SPV. All the financing documents with the lenders will be negotiated with the SPV. The power purchase agreement will be with the off-taker and the SPV. There would be any kind of arrangement with the government, like implementation agreement in case of major issue like force majeure or for instance expropriation, because we are seeing that governments are changing every 5 years, and if a new government or there is a coup d'état that is bringing a new government, the project company and the lenders need some reassurance from the government that they will be able to preclude for any kind of similar events. And then you also have to get into agreements with the grid operator. So there are various agreements like system operation agreements, That is enabling the system operator to balance the system. So for instance, here you can find penalties for any errors in the forecasting. So we mentioned the importance in the previous presentation. We mentioned the importance of forecasting well the renewables, and here the grid operator is ensuring that you are doing so with a penalty and incentives framework. And then also the grid connection, so the grid code mainly, respecting the grid code in an agreement, and also transmission use of system. It's what we call the wheeling agreement. And then the mine is also having a power supply agreement to ensure that they can provide all their energy. So I see time is going very fast. I just wanted to. I said at some point that we are also talking about people, and here is some example about the work that has been done on the wind site to ensure that we are upgrading the roads to bring the equipment on the place. So this is, for instance, benefiting to all the communities that are surrounding the area. Here is a picture of a local ceremony of the Chewa community, which is called Kulamba, that is occurring at the end of August, where also Total Energy is sponsoring the event that is quite important. Here, this event gathers around 1 million people each year. So it's quite an important event for the communities. And as I mentioned, so in the left, in the right-hand side, the communities is also bringing the land in exchange of dividends in the project. So this is some kind of opportunities that are also brought by the project and benefiting to the local communities. Yeah, I will be quick, but if there is any question, please feel free to ask. So, in terms of conclusion, uh, so developing renewable energies in emerging countries is often there are often plenty of opportunities, there are plenty of things to be done in such countries. The demand is growing tremendously. The resources are often very good. There are still millions of people without energy or power at their households, and renewables are often found the cheapest and fastest to build compared to nuclear power plants or hydropower plants that also have big impacts to environment and society. Though there are a lot of risks as well. The grids can either be weak or they are not existing. You need to build additional interconnection to ensure that you are bringing you can bring your the project that is with the best wind or solar resources to the grid, and often it's far away from the existing infrastructure and in the existing demand sites. So there is that. Then there is also the off-taker credit risk. So often, especially in regulated markets, you need to sell your power to the national utility, and often they are in bankruptcy, so the lenders wouldn't be able to finance your project. So here it's also important that you can find solid off-taker. And in our instance, for example, that I didn't mention, but here you're bringing renewable into the country that is bought by a mine, so it's enabling all the hydropower that is cheap and that is amortized to go to the rest of the demand, so to the people. So this is why these kind of schemes is a win-win for both the governments and the industrial players. Then you also have often evolving regulation, long permitting, and political change that can also hinder a project. Last but not least, the importance of bringing a strong agreement framework is key to ensure that you can finance your project and bring all the multilaterals and lenders to your to finance and to ensure your project so it's bankable and that you can make it live. So thank you very much for listening, and I would be keen on answering any kind of questions you may have.
Thank you very much, Antoine. Very nice, very nice parkour. Very nice job. System engineering. Full.
Thank you, Professor.
Okay. So, questions, please. Thank you very much. Yes, of course. Thank you very much. Questions, please. Guys, questions by the chat also, if you can send, you like to send questions. Están tímidos.
Well, that's okay. I just thought it was yeah, it would be interesting for you to see how actual projects are made, and not only from the technical parts. And I used to be on the technical side initially, and now I'm seeing all the different aspects of a project, and we can see that technical is only a part of it, and it's not the sole piece of the puzzle to be solved in order to actually build actual infrastructure to developing countries, for instance.
Okay. Okay. Thank you very much. Maybe
Well,
maybe I have I don't know if there is a question of the audience. If not, I would like to ask. So you said that you 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 are the lead of the project until you give the project to the to executors to execution, and then you take another project, or you have some relationship with the implementation phases, or not. You give the project, and you take another option, another study.
yes, it depends actually. Some of my colleagues would keep following the projects, so then they would keep
Okay,
managing the construction. Some would be just doing the handover to another team, and then go for another project. So it depends on
very
career path. But
very
basically, when you're at my position, you just keep at the same job, and then you just take the return on experience that you've done on one project to replicate to another one in another area or another country or in the same area sometimes. Depends.
okay. Okay, interesting. Very nice job. Very nice job. Okay, thank you very much, Antoine, for your presentation. Um,
Well, thank you all. Thank you for the attendance, and I hope
yes.
that it was helpful. So
Can
please have a nice day, and we keep
Thank
in
you very
touch.
much.
Bye
I
bye.
can give you I can give your contact
Yes, if
to
there is any
the
question or anyone wants to reach out, please feel free.
okay,
My address is antoine.monterrat at totalenergies.com. But please feel free
okay.
to share my details to anyone that would be interested into entering in contact. It would be
Okay.
a pleasure. So
Thank
thank
you.
Thank
you
you very
again.
much.
Muchas gracias a todos.
Muchas gracias. Que estés muy bien.
Gracias.
Gracias.